Hey, how's it going? This video is going to cover section 3.5, which is looking at parallel and perpendicular lines. All right, so here our first question. We have a set of 5 lines. We want to determine which are parallel and which are perpendicular. So parallel lines, by definition, have the same slope. And perpendicular lines have slopes whose product is -1. So product of slopes equals -1. All right. So let's go ahead and start with line R, right? This is the pink line. So line R has slope. Well, because we have points on the line, we can count the rise and the run. Okay, so I need to go down 1, 2, 3, and over 1, 2, 3, 4, right? So that was down 3 and forward 4. So line R has a slope of -3/4. Sorry, let me adjust the camera there. All right, let's move on to line S, which is the orange line. Okay, so I'm going to find a point and count vertically and horizontally to the next point. So it looks like it's down 3, 1, 2, 3, and forward 3, 1, 2, 3. So that'd be -3/3, and that is just the same as -1. Our yellow line is line T. Okay, and we have a point here and a point here. So let's see, 1, 2, 3 spaces down, 1, 2, 3, 4 spaces forward. So that was down 3, forward 4. All right, let's take a look at the blue and the green lines. So these lines you can see are going up. So they have positive slopes. The first 3 lines we looked at were trending down, so they had negative slopes. Okay, so line P is the blue line. So there's a point. Let's see, there's a point here and a point here. So that's 1, 2, 3 up, 1, 2, 3 forward. So 3/3, which is +1. Green line, which is named line Q. Let's find 2 points. There's a point here and a point here. So that's up 1, 2, 3, and forward 1, 2, 3. So that also has a slope of 3/3, which is 1. So the question is, which lines are parallel? And we said that the 2 lines have to have the same slope. Okay, so I can see that line R and line T both have a slope of -3/4, so they are parallel. And so we can mark parallel lines in the figure with little red arrows. Okay, so R and T are parallel. And I can see that line P and Q both have a slope of 1, so they are parallel as well. So I'll use a double arrow for those lines. Okay, so the blue and green lines are parallel, the pink and the yellow lines are parallel. Okay, all right, which lines are perpendicular, right? This means that if I multiply their slopes, the result would be -1. Okay. Well, if I multiply 1 and -1, that product is -1. So I can say the blue and the orange lines are perpendicular, and we can show that with the little red square symbol. But also, if I take the slope of the green line and multiply it with the slope of the orange line, 1 times -1 gives a product of -1 as well. Okay, so the green and orange lines are also perpendicular. Okay. So we have two sets of perpendicular lines, and we have two sets of parallel lines. Okay, so next question is to determine whether the lines here given by these points are parallel, perpendicular, or neither. And so we had mentioned that parallel means that they have the same slope. Okay, so the slopes are equal. Perpendicular means that the product of the slopes is -1. And then neither would just be any other case. So if the slopes were not the same and they didn't, sorry, this should be a -1. Okay. If the slopes were not the same and the product was not -1, then neither would capture everything else. All right, so we don't have any pictures to go off of like in the last problem. So we're going to have to calculate the slope using the slope formula. Okay. So the formula for the slope is y2 minus y1. Okay, so it's the difference in the y coordinates divided by x2 minus x1. Right, it's the difference in the x coordinates. Okay. Right, so let's go ahead and label. Okay, so that's our formula. Okay, and then let's look at line 1, and I'll label things. So this will be x1, y1 since it's the first point, and this will be x2, y2 because it's the second point. So line 1 will have a slope of, let's see, y2 minus y1. So that's going to be 2 minus 0. And then x2 minus x1, that'll be -2 minus 2. Okay, so 2 minus 0 is 2. -2 minus 2 is -4. So this simplifies to -1/2. All right, let's do the same thing for line number 2. So again, we need to label the coordinates. This will be x1, y1, x2, and y2. All right, so our slope for line 2, okay, go back to the formula, y2 minus y1. So that's going to be 4 minus -2. And then x2 minus x1, that's going to be 4 minus 1. x2 minus x1. Okay, 4 minus -2 is 6. 4 minus 1 is 3. 6 divided by 3 is 2. Okay. All right, so now let's compare the slopes. Are they the same? -1/2 and +2. No, those are not the same. Okay, so we know that these two lines will not be parallel. Okay, is the product -1? Oh, let's see. -1/2 times 2 is -1. All right, so our two lines are perpendicular. Okay. When you multiply their slopes, you get a product of -1. Okay, so next what we're going to do is we're going to use an equation of a line that's already given, and then another point, and see if we can find a second line that passes through this point, but in this case is parallel to the first line. So we should probably remind ourselves that anytime we see the word parallel, that means that the two lines will have the same slope. Right. So what do we know about the second line? Well, we know that for any line, we can write the equation as y equals mx plus b. And since our second line has to have the same slope as the first line, right? Let's identify the slope of the first line. It's 2/3. Okay, so we know now that m will be 2/3. We also know point, right? So we have an x and a y value, right? And this point is going to be on our second line. Okay, so we know that we have an x value of 3 and we have a y value of -2. Okay, and so we can take those three values, the m value, the x value, the y value, substitute into our slope-intercept form, and then we can use that to figure out the intercept of the line. That's the only thing that we don't know. All right, so -2 equals 2/3 times 3 plus b. Okay. Well, I see here that I have reciprocals, right? 3 in the denominator times 3 an integer. Right, so those are going to cancel each other out. So get -2 equals 2 plus b. Okay, we can subtract 2 from both sides, and we would get -4 equals b. All right, so the important things here is the slope of the second line is going to be 2/3. It has to be the same as the original line. And now we know the y-intercept of the second line is -4. So the equation of the second line is going to be y equals mx plus b. So m is 2/3 and b is -4. All right, so let's graph these. Okay, so we'll make the y-axis and an x-axis. Okay, let me graph the original line first. Okay, this line has a y-intercept of -1 and a slope of 2/3. Okay, so up 2 over 3, up 2 over 3. And then our second line, this one has a intercept of -4, 2, 3, 4, but the same slope, 2/3. Up 2 over 3, up 2 over 3. All right, and we should probably also double check that our second line passes through the point 3, -2, which it does. This is 3, -2 right here. Okay, last question. Write an equation of the line passing through point P, coordinates -2, 2, that is perpendicular to the line y equals 2x plus 3, and then we're going to graph both of the lines. So remember, perpendicular means the product of the slopes will equal -1. Okay. Product of the slopes is going to equal -1. So I know that the first line has a slope of 2. So let me write m1 equals 2, right? So m is the letter we use for the slope. I'm using a 1 to indicate it's from the first line. Okay. And m2, that'll represent the slope of the second line, but I don't know it. Okay. But what I do know is that the product will equal -1. Okay. So I know that m1 times m2 will equal -1. And then I can substitute the slope of the first line. So 2 times m2 equals -1. Okay. And now if I just divide both sides by 2, I can solve for the second slope. So m2 is going to be -1/2. All All right, so we have the slope for the second line now. Okay. We also know an x and a y value for a point on the second line. Okay, so just like what we did in the last problem, we're going to start with our slope-intercept form. Okay, this is our slope for the second line, so we can plug it in. This is an x value and a y value for a point on the second line, so we can plug those in as well. Okay, so y will be 2, m, the slope is -1/2, and x value is -2, and b represents the y-intercept, which we don't know, but we'll solve for it. All right, so 2 is going to equal, right, a negative times a negative is a positive, a half times 2, well, this is just going to be +1, plus b. Okay, we can subtract 1 from both sides, so we would get 1 equals b. So we had already found the slope of our second line, and now we know the y-intercept of our second line. So let's write the equation. So the equation of the second line, y equals mx plus b. Okay, so m is -1/2 and b is 1. Okay, mx plus b. All right, time to graph. Okay, so we'll graph the original line first. Okay, y equals 2x plus 3. So 3 is the y-intercept. 2 is the same as 2 over 1. All right, so we're going to go up 2 over 1, up 2 over 1. Okay. Right, and then here's the equation of our second line. This line has an intercept of 1, okay, and the slope is -1/2. So down 1 over 2, down 1 over 2, down 1 over 2. And so what we do want to just double check is that our second line passes through the point -2, 2. So if we go -2, 2, yes, we can see that that point does fall on our second line. And from the looks of things, these do look like they're perpendicular, right? They cross at a 90-degree angle. All right, so thanks for watching. I hope you found this video helpful and that it's going to prepare you for our breakout room work next class.